Hi everyone. If you guys can hear me, am I audible to you guys? And am I visible to you guys? Can you guys please write yes in the comments so that we can assure a smooth experience throughout the stream. Just write yes in the comments if you can hear me and you can. Am I if I'm visible to you guys? All right then. I hope you all of you are doing good. And this is Harsh Agarwal, product manager at GeeksforGeeks. And before we begin with today's session, I would like to announce something. We have decided to provide a certificate of participation to all of you who will attend this workshop today, right? And the thing is, we have to all of you will have to follow a certain process to be eligible for the certificate. I will We will announce five characters throughout the session, in intervals, every character in an interval of say 15 to 20 minutes. And the all of those five characters combined will make a code, and you guys need to paste that code in the comment section at the end of the session, right? And if you guys paste the right code, I will let you know the process to be followed to be eligible for the certificate. Fine. Make sure you pay attention throughout the session, and you observe five characters, and combine will make a correct code which will be used to get the certificate, right? The first code is C. The first character is C. I hereby announce the first character. The first character is C. And along with this, we have some major announcement at the end of the session as well. So make sure you pay attention throughout the session and you stay till the end. And it will be really helpful if you guys can share this session to your friends so that they can also join and be eligible for the certificate and be able to learn what all things we are going to teach in the session, right? So let's start with this session. We will begin with with some doubts that people have asked us in tomorrow's session. They have filled a form with a lot of doubts, and we have shortlisted some common doubts to be discussed in today's session. So I will just move straight away. I will just go straight away with the doubts. The first doubt that someone asked is everybody explains data structures algorithms using C++. Why can't they explain it using Java or any other language? You need to understand this in this way, that data structures and algorithm is not restricted to any programming language, right? Maybe the person who is explaining it in C++ is well versed with C++, right? Data structure and algorithms are independent of a programming language. You need to learn how those data structures work, internally, how the operations are performed on those data structures, and you can use your knowledge of a particular programming language to implement that data structure, right? So if someone is explaining a particular data structure using C++, then he or she or that person must be well versed with C++, right? That's why they chose C++. So it does not matter whether someone is explaining it in Java or someone explaining it in Python or someone explaining it in any other language. What you should focus more on, which data structure they are explaining, how does those data structures work internally, and what are the operations performed on those data structures, and how are those operations performed, so that you can implement those data structures in any programming language of your choice, right? So the next question that a lot of people ask is, can you tell us what is the correct order of topics so that someone can master data structures and algorithms? So there can be different formats for different persons. It varies from individuals to individuals, but I will just give you a basic path that you can follow in terms of the topics, right? So the very important and the first and the foremost important topic is to learn time complexity analysis, which I taught you guys in yesterday's session as well. The first few minutes of the session was on time complexity analysis. So it is very much important to be aware of time complexity analysis, and what amount of time is taken by your program that you have wrote for a particular problem, right? So it is very important to know time complexity analysis. So you must focus on learning time complexity analysis first, and then there are generally two kind of data structures: linear data structures and non-linear data structures. Linear data structures are arrays, linked lists, stacks, queues, and non-linear are trees, binary search trees, heaps, tries. These are graph, and these are non-linear data structures. So you must go with linear data structures first. Like the correct order would be to learn arrays first, solve a lot of problems on arrays until you get comfortable with implementation of arrays and using different algorithms on arrays like searching and sorting. So learn arrays, use searching and sorting algorithms to perform to solve different problems and a lot of problems specifically on arrays. Then move on to learn linked list. Then you may go for stacks, queues. Then move on to non-linear data structures like trees, BSTs. Then you may go with recursion and then graph. Then other algorithms like greedy, backtracking, dynamic programming, etc. So the next question is, learning interview problems, should one prepare, should one just simply learn interview problems, or should one go with competitive programming, or should one do projects to get a job into product based companies like Flipkart, Amazon, Netflix, Google, etc. So see, you must have to understand it in this way that you must have to focus on what all things, or what all things a company focuses to hire a candidate, right? The major thing that these companies look in a candidate is good problem solving skills. So all you need to do is good problem solving skills. What do we mean by problem solving skills? The thing that we mean by problem solving is you need to be good at solving a problem, solving a coding problem using that uses knowledge of data structures algorithms in a constrained time, in a definite amount of time, right? So this is what is called problem solving. You may develop problem solving by solving problems on your own, by uh, taking participations in different competitive programming contests. Competitive programming actually helps a lot in improving your problem solving skills, but it is not the only way by which you can improve your problem solving skills. Problem solving is just about solving problems in a given amount of time, right? In a solving problem within time constraint. Like you will be assigned say half an hour or 30 minutes to solve a particular problem, and you need to solve that particular problem in the assigned amount of time, right? So you need to be very good at data structures, algorithms, and how to use those data structures and algorithms to solve a particular coding problem, right? And this thing can be developed only by repeated practice and a continuous practice over a period of time. So all you need to do is practice problems, practice coding problems, practice your knowledge, practice how you can implement your knowledge, and all of these things. And that is how you can improve your problem solving ability. It is not necessary that you go for competitive programming, and that is the only way to improve problem solving. There are a lot of other ways as well. Like if you go through our website, GeeksforGeeks, we conduct regular contests. We have some paid courses which have a lot of problems. We teach how to solve those problems. We actually have a lot of contests which consist of interview kind of problems, and you need to solve those problems within a particular amount of time allotted, right? So all you need to do is solve problems, practice problem solving, improve your problem solving skills. So this is one thing. Another thing is, what about projects? See, it is better to do, if you are a fresher or you are in a college, it is better to have some amount of knowledge on how things work behind the scenes, right? It is better to have some amount of knowledge. So while developing projects, make sure that it uses different concepts of computer science. Like it uses DBMS. It must be interacting with databases. It must be trying to solve some particular problem, or and also make sure that you are well versed with your project, right? You must be well versed with the project that you are doing. Like you must be ready to answer any question related to the project that you are doing. So another question is, want to know about how to prepare for service based companies in very short amount of time. So see, there is nothing you can do from scratch in a very short amount of time. short amount of time only implies to when you are revising or when you are recalling things that you have already learned, right? You cannot do your entire interview preparation in just a week of time, just in just 7 days or just 5 days or just 2 days. All you can do is you can just revise those things, or you can just do last minute preparations. So if you want to quickly do your last minute preparations related to different subjects, you may check out last minute notes on Gigs for Gigs. Just go to our website and type last minute notes of a particular subject with a subject name, and you will get a list of last minute notes which you can prepare. Another thing, for service based companies, we have a lot of links. Like you can search for TCS interview preparation on Gigs for Gigs. You will get a definite process that you need to follow to be well prepared for the interviews of TCS. And we have this content for every service based companies, for almost every service based company. So another question that a lot of people ask is, what are some important books for data structures and algorithms? So see, if you are someone who prefers books for learning programming, or prefers books in general, or you have a reading habit, that's a very good habit. And to name some books, I would like to name Introduction to Algorithm by Thomas Corman. Another good book would be to prepare for interviews is by Narsimha Karumanchi. It is also named, the name of the book is Data Structure and Algorithms by Made Easy, right? So you may follow these two books if you are preparing for interviews. These two books will help you a lot to enhance your knowledge of data structures and specifically algorithms to a great extent. And one more question that a lot of people repeatedly asked, despite of me answering this question in yesterday's session as well, like which language to opt for data structures and algorithms. Like I have also told this repeatedly, that data structure and algorithms are not restricted to any particular programming language. Programming language must not be a barrier, or choosing a programming language must not be a barrier when you are going to learn data structures and algorithms, right? Because you can implement what you have learned in any programming language of your choice. So you may go with any one of the programming language, that is object oriented programming language, which supports classes and everything else. And you may start learning data structure algorithms, implement those data structures in the language you have learned, and that's all about it. Like choosing a programming language must not be a barrier if you want to learn data structure algorithms. So that's all from the doubts perspective. So the first character I already announced was C. uh, I would like to ask Himanshi now to join the session and explain different data structures which we are going to explain today. So I'll be adding her on the stream, and she will let you know further characters. And I would just like to say that just stick through the webinar, learn the concepts of data structures that we are going to teach you. This will be very helpful in your career, and just be present, pay attention to the webinar. So
Hello
hi
everyone.
Himanshi.
Hello everyone. I just hope you all are doing well. Okay. So let's start with our task today. So in today's class we are going to discuss some left out data structures, like we have stacks, queues and trees, right? Is my screen shared now?
No, Himanshi, actually
Hello,
your
are you able to
screen is
see
not
me?
visible.
Just a second. Is it visible now?
Yes, it is visible.
Okay, great. So let's start with our first data structure, stacks, right? These are the data structures that we're going to discuss in today's session. Stacks, queues, and trees, right? So these, as Harsh has told you, that these are the basic data structures which we can say as linear data structures, right? And this tree is another, type of primary data structure, but it is actually not linear, right? So we'll be discussing the differences, like what are the differences in these ones. So let's start with our first data structure, that is text, right? So, what exactly are stacks? Like, what is stack actually? So stack is, something, as I have told you, it is a linear data structure, and it is, we can say, abstract data type, right? The operations that will be performed inside it are, followed in a particular order only. Like you can't delete an element from between, like you can't go to the ith element and access that or delete that, right? It can be done in a, I can say, particular order only, right? For example, say I have this stack of books, right? And it contains these books, one, two, three, four, six, any number of books, right? So if I want to insert a book here, what I need to do, uh, actually, if you'll be inserting a book in the stack, you need to insert it at the top, right? And if you want to delete a book from the stack, again, you'll be deleting it from the top. Say I have a book, right? And I want to insert it. Where you'll be inserting it? It will be inserted here, right? Just above the stack of books, right? And say now you want to remove it, it will be removed from the top only, right? Okay, so basically stacks is something from which last element inserted will be deleted first, and you need to push elements in the top only, right? So it is last in, first out, right? This is last in, first out. It follows last in, first out operations, right? Let's discuss some other example. Like, say we have a stack of chairs, right? So the chair that is in the top of the all the chairs will be removed first. If you want to remove some chair, the top chair will be removed first, right? And if you want to insert a new chair inside it, it will be inserted at the top, right? So it has just one entry point from where you can enter element, and one exit point, right? So this is the condition of stacks, that only one entry point will be there and only one exit point will be there, right? Okay. So let's discuss how we can implement stacks. So to implement stacks, let's first discuss like what is the thing that I have told you. That is, it is restricted to a few operations only, right? You can't insert the element at the ith position. If you want to do that, you need to remove all the elements just below, just above the ith element, right? So for that purpose, we know that thing that there are some constraints, right? There's some restriction, and we know that if there are some restrictions of these kinds, we need to use classes, right? So here as well, to implement the stack, we'll be using a class, which will be class stack, right? Okay, so I have named my class as stack. What are the things that I need to do here inside this class? So let's discuss what are the operations you can do on a stack. I can insert something inside my stack. Okay, so this is my stack, right? It is empty right now. What I can do is I can insert element inside the stack. So I'm doing insert one. So one will be inserted at the top. As it is empty, this will be the first element here, right? Now say I want to insert 2 here. So where will 2 be inserted? Just above 1. Because this is the topmost location now. So you need to insert 2 here, right? Now say I want to insert 3. So it's again, you need to insert it at the top again, right? Now say I want to delete something from it. Do I need to pass anything here? No, because I know that the element will be deleted from the top only, right? So which is the topmost element? This 3 is the topmost element here, right? So this 3 will be deleted, right? So as soon as I'll write this statement, this 3 will be deleted from here. Okay. Now say again I'm doing delete. So this 2 will be deleted this time because 3 has been already removed, and this is the top element now, right? So let's remove that, and this is the status of a stack now. It contains only one element, right? Which is 1, right? Okay. Now let's discuss some other operations that we can perform over it. So let's say I want to check the topmost element, like which is the topmost element present on the stack. So as the stack has only one element, so this will be the topmost only, right? So it will return 1 for me. Okay. If it will be having one, two, three, four, these elements, so what will be the topmost element here? 4 will be the topmost element, and 4 will be returned in this case, right? Okay. So now let's say I want to check the size. So what is the size? Size is actually the number of elements inside my stack. How many elements are there in this stack? 1, 2, 3, 4. Right? 4 elements are there, so size will be 4, right? And in this case, only one element is there, so size will be 1, right? Okay, so this is how you can check the size. And let's check the last operation that we're going to do over it is empty. So is empty is basically to check that if your stack is empty or not. So if your stack has some elements inside it, basically means that it is not empty. Otherwise, it is empty, right? So how you can check that? You can check it with the help of the size. When will be the size 1 or greater than 1? It will be when stack has some elements, right? And when will it be zero? When the stack doesn't have any elements. If the stack don't have any elements, basically means that it will be empty, right? So what I need to do, I need to check if my size is zero. I can simply return true that yeah, my stack is empty here, right? In else case, I need to return false that it contains some elements, right? Just like in this case, my size is 4, it will come to this condition. It will check if my size is 0. As it is not 0, it will come to the else condition directly and return false for you, right? So these are the basic operations that we're going to perform over stack. Now let's see how we can implement these operations. So what I need to do, I need to implement all those operations. For implementing stack, we can have two options. Either you can implement it using arrays or you can implement it using linked list, right? So say I want to implement it using arrays. I have created an array and this is my stack. I want to insert one and say I have taken the size 5 here, right? Say I have taken the element 1. Insert this one here. Okay. So its size will be 5, right? Now I want to insert 2. Insert 2 here. Now I want to insert 3. Insert 3 here. Insert 4. 4 will be inserted here. Insert 5. 5 will be inserted here. And now I want to insert 6. Where the 6 will go? Arrays has this disadvantage that size has to be fixed. Do whatever you want to do into this part, but you are not allowed to access either after it or before it, right? You can do only this, like you can access only this part, you can change only this part, but you can't access the part that is outside it. Like you can't access other memory locations, right? So this operation will fail at some point, right? When the size of array will be smaller and I want to insert more elements in the stack, right? So we'll be implementing stack using linked list. Okay, so let's start it using linked list. So what is the first operation? First operation is to insert something. Say I want to insert something inside my stack. So in case of linked list, we have nodes, right? Say I want to create this stack. Let's draw it here. 1, 2, 3, 4. I want to make this stack. So what are these elements? These elements will be represented in form of nodes in case of linked list, right? Your linked list should look like this: 1, 2, 3, and 4, right? And if you want to insert something new, some new element, it will be inserted after 4 because this is the topmost element. You can check it from here. If you want to delete something, this 4 will be deleted. If you want to check the top element, so now this 4 has been deleted. So 3 will be the top element, right? This one. And if you want to check the size, so the size of the stack will be the length of this list, right? Okay, and is empty function can be checked using the size itself, right? So let's start with insert function first of all. Say I want to insert one first, right? So what I need to do, let's say I have created a node. We know how to create nodes in linked list, right? A node will be created with data 1 inside it, right? And what is this? This is the block to contain the address of the next element, the next node, I can say. As this is the first node itself, it will be null, right? Okay, so I have done, I have created a node with data 1 and this is null, right? Now say I have another operation that is insert again and it is 2. Okay, so another node will be created with data 2 inside it and this will be null, right? So this is my new node now. And we know that the first node is always the head node of a list, right? With the help of which we can traverse the complete list. So say this is an address 100 and this is an address 200. Now what I need to do if I want to connect them, I want to pass this address into the heads next, right? So this is my heads next. So just remove this, replace it by 200, and as soon as you'll be doing this node will be connected to this node like this, right? Now my head is this and the new node inserted is this, and the linked list created is this is 1, this is 2, and after that we have null so far, right? Okay. Now say I want to insert 3 now. So what I need to do, I need to insert 3 here. Okay, so now this has data 3 inside it and this will be null, right? Now the next node here, right? The next node that you want to insert. So it will be 300 this time and this node will be created like this link will be created. As soon as you'll be replacing it by 300, this link will be created, right? And this is your new node now. Okay, so your list is now this is 3, right? Instead of this null, now we have 3 here and this is null now. Okay. Now say I want to insert 4. So if I want to insert 4, what I need to do? Again, a new node will be created and 4 data and this will be null, right? So how can you attach it with this? What you need to do is you need to traverse over the complete list, right? Because do you have the address of this node, this 300? This 300 is with this node only, right? We don't have the address with address of this node. This node contains the address of this node, right? Similarly, the address of this node is contained by this node, right? So we need to start from the head node itself. We'll start traversing it, and as soon as we'll be coming here, what I need to do, say this is an address 400, I have to replace it by 400 and attach this link, like create this link, right? So now my linked list will be something like this. This will be 4 and this will be null, right? So how much time it has taken? It has taken like you are traversing over all the nodes, right? Starting from the first node. This is the first node, second node, third node. So before inserting this, how many nodes were there in the list? 3 nodes were there, and you were traversing over all the 3 nodes. So say I have n nodes inside my list. So what is the complexity? Like, what will be the time complexity? You are traversing over all the n nodes, right? So time complexity will be O of n, which is okay, but we need to improve it. Say I want I want a complexity O of 1. I don't want this, O of n. So let's further improve it. Let's try to do something else inside it. Say I have, I want to insert 1 again. So a node will be created with data 1 inside it, and this will be null, right? This will be the head node. Let's take another pointer that will be pointing on this head node itself. Let's take it as tail. And now say you want to insert 2, right? Another node will be created with data 2 inside it, and this will be null, right? Okay. Now I need to connect them. I need to connect both of these nodes, right? So say this is on address 100, this is on 200. So you need to replace it with 200 and then you need to connect it like this. As soon as you connect it like this, just remove the tail from here and come to the next node. So what I am doing is I'm inserting in tails next. This is my new node, right? So in tails next, I'm inserting the address of n. N is this node, right? So initially this was tail. In tails next, I have inserted this 200, right? And then I'm doing tail is equal to tails next, right? So as soon as you write this statement, this tail will come here from there, right? So now my tail will be pointing at this node, this new node, right? The last inserted node we can say. Now say I want to insert 3. Again, a new node will be created and 3 and null, right? And again, you need to do this similar task. In tails next, this is tails, so this is an address 300. This will be a new node now. In tails next, what we are doing, you are passing the address of n. Address of n is 300. So this will be 300 this time. And as soon as you'll be doing this thing, this link will be created, right? And then you need to do tail is equal to tails next. Remove tail from here and tail will come here this time, right? Now let's see for some other example. Say I want to insert 4 this time. A new node will be created with data 4 inside it and this will be null, right? What I'm doing here, am I traversing over the complete list? No, I'm just working with this tail, right? What I am doing is, say this is an address 400. I'm connecting these nodes only. I'm working over these last 2 nodes, the last node of the list and the node that you want to insert inside it, right? So inside tails next, what you are doing again, inserting n's address. So 400 will come here, and you need to connect this. Tail is equal to tails next. So how much time it is taking? Basically, you are just performing these operations. It will be taking some k constant time, right? And we can effectively say that it will be taking some constant time. The time complexity will be constant, right? Which is O of 1. So we have improved from O of n to O of 1 with the help of this tail pointer, right? But say I want to perform all the operations like the pop, top, size, and is empty, all in O of 1, right? So I have achieved O of 1 in my function, but let's check it for pop and other functions as well. So now say I want to delete element. This is your list. This is the status. This is 1, 2, 3, and 4, right? And so this is null. And you want to pop element from here. Here we have our head, and this is your tail, right? We have discussed this thing. If you want to delete some element from here, what you can do is the last inserted element is this one, this 4, right? We know this thing. The last inserted node was this 4. So I need to delete this 4 from here. So this 4, this tail has the address of this 4 node, and you can, simply delete tail. So what I am doing is just delete tail for me, and I'll be done. This node will be removed, and now I'll be having 1, 2, 3 in my list only. Now say I have again called the function pop. Again, what you'll be doing is you need to delete tail. But your tail has been lost with this fourth node itself. Where is this tail now? Can you somehow do tail is equal to tail's previous? No, you can't do that, right? Because inside a singly linked list, we can't backtrack. We can't, come to the previous node, right? So we can't do this thing. Okay. So what we need to do now? Okay. So the next character for your code is E. I repeat, the next character is E. Okay. So what I am doing here is, like this tail has been removed, right? And this is my status now. And I'm again deleting this. So this tail has been lost. And if you'll be doing this delete tail again, there's no tail now, right? So basically nothing will be deleted and the list will be as it is, right? So again, you need to traverse from the head node and go to this node and delete it, right? Like if you want to delete it one time, then it will work fine. But if you want to delete more than one items, then it will fail, right? Then again, it will come to the O of n solution. But I want O of 1 here. I don't want O of n, right? So again, I need to do something. So let's try to do something else with this pop function. Say this is my list, 1, 2, and 3 and 4. These are the elements. And this is null, right? Here I have head, and initially the tail was also here, but now your tail is here. And say I have maintained another variable with it, another pointer with it, that will be pointing at the previous of the tail, like here, right? Because initially, say this was your node, this was 1, head was here, tail was here. As soon as you do tail is, and so previous is on null, right? So as soon as you do tail is equal to tails next for the first time, take previous to the head, right? So your previous will come here and say this is your new node, right? Tail is here. So previous is here, tail is here. There's one difference, like difference of one node, right? Now next time when you'll be doing tail is equal to tails next, then do previous is equal to previous next, right? So in that way you can come to the last point, like when tail will be at the last node, previous will be at the second last node, right? Now let's say I want to delete the element now. So what I can do now, simply delete tail. But before deleting tail, do one thing. Let's take another pointer here. Let's say it is temp. Okay. What I'm doing is at the last node, temp is pointing now, right? As soon as your temp is pointing at the last node, do tail is equal to previous. Okay. Take this tail to the previous pointer here. And now your tail is pointing here and remove this one, right? So this one has been removed successfully. Now the status is this only, 1, 2, 3. Okay, now say again I want to delete. Okay, so if I want to delete it again, what you need to do? Again, you need to, you can delete it with the help of this previous and tail if you want to delete. But you again need to do this thing. Tail is equal to previous. But how will you do that? Your previous is here. There is no previous here or here. Like a list can have any number of nodes, and I want to delete any number of nodes from it. But this is the status when you will be, deleting two elements. Two elements can be deleted in O of 1, right? So obviously we'll not be, taking the pointer to each and every node in the list. We will have to do something else. And we know that with the help of this head and tail, we can't achieve O of 1, right? So let's try to change our push function again. So what I'm saying is, I'm changing the push function again, right? So I want to insert 1 now. A new node will be created with data 1 inside it, and this will be null, right? Okay. This will be head this time, and this will be your new node itself. Now say I want to insert 2. So as soon as you'll do this thing, a new node will be created with data 2 inside it, and this will be null, right? And now this time, this will be your new node. This is your head node. So what you were doing in the previous thing, solution was you were attaching this like this. Like this link will be created, right? But I don't want to create this link now. I want to insert the new element in the beginning, right? I want to create this link now, right? What I want to do is instead of doing this thing, I want to do this thing. Okay. Like every time a new node will come, it will be inserted at the beginning. Okay, so it has been inserted in the beginning. So this is your head, and you know that this is your tail. the first node should be the head node. So somehow I should manage to, make this node as my head node. And as you need to attach this link as well, what you need to do in ends next, this is your end, right? In ends next, pass the address of head. What is head? Head is the address of this node, right? Head basically contains the address of this node. So this is 100 and this is 200, right? So in ends next, you have done head. So this will be replaced by 100, right? So now we have 100 here. As soon as you'll do this thing, this link will be created this time, right? Okay, so now the status is this is your 2 and this is your wait, and 1 is now pointing to null only. And this is your head now, right? Now what you need to do, just take head to n. You know this node is n, right? Take head to n. So stop, our head will stop pointing here, but head will start pointing to this point now, right? So now your head is here. Okay. Now say I want to again insert 3. So a new node will be created and with data 3 inside it, and this will be null. Again, you need to follow these steps. In ends next, this will be a new node this time, right? In ends next, pass the address of head. Head is our 200 now. So remove this and write 200 here. As soon as you'll be doing this thing, this link will be created. And now this link will be created and this will be your first node now, right? So what you need to do now, head is equal to n. So head is this one and this is n. So you are doing head is equal to n. So head will start pointing at n. So now this is your head, right? Okay, so I have done this thing. Now say I want to insert 4. Now let's see how much time will it take to insert 4 here. So a new node has been created with data 4 inside it and this is null, right? What I am doing is in ends next, this is your end, right? In ends next, you need to pass the address of head. Head is this one. So this is on 300. You are passing 300 here. 300 has been successfully passed, right? And this link has been created, like this link, right? And then you are doing head is equal to n. So your head will start pointing here now. And your linked list has been created like this. The first node, this is the second node, third node, and fourth node, right? So how much time it is taking? You're just working with this node and this node, right? You're not touching the rest of the list. You're just working with the last node of the list, and the new node that you want to insert, right? So it will take some k time, right? To perform these operations, it will be taking some constant time, and we can say O of 1 time, right? So push is again done in O of 1 if we'll be, inserting the elements in the beginning. Okay, now let's check it for top again. Sorry, pop, delete function. So what I have done is, if this is my stack, this is 1, 2, 3, and 4, right? So what I have done is, I have created a list like this. 4 should be at the head node, and then 3. This should be 2, and this should be 1, right? And this should point to null now. Okay. Now say I want to delete something from it. So which is the topmost element? 4, right? You need to delete 4 from here. And 4 is where? 4 is the head node itself. So is it okay if I'll be deleting this head? If I'll be deleting this head, basically, my linked list will be lost because this node contains the address of this node and this node contains the address of this node and so on, right? So I need to do something like, this list should be preserved and this should be removed, right? So what I'm saying is, just do one thing, take another pointer variable here, temp, right? I need to do this thing, node start temp should point to head, okay? And then do head is equal to head next. And then you can simply delete temp, right? What I have done, I have created a temp variable, temp pointer variable, which is pointing at head. Then I have done head is equal to head next. This is head, remove it, and now head will be pointing here. And then delete temp. This will be deleted now, and status is this much only, right? This one is my list. Okay, now sir, again I want to delete something. So again, you need to perform these operations only. Take temp here, do head is equal to heads next, and delete temp. This will be deleted, right? So this is your list now. So in the same way, you can delete any number of nodes you want, right? And how much time is it taking? You are just, taking a temp variable and doing head is equal to head next and deleting it. Basically, some k constant time, right? Again, O of 1 only. So we have achieved O of 1 during deleting and during inserting the element, right? Now let's check it for top and top element. If you want to check the top element or you want to check the size or is empty, right? So this was my list left, 2 and 1, right? All the elements were deleted. Now say I have called the top function here. Which is the top element? This was your head, right? This is your top element, and you need to return true. Sorry, 2 from here, right? So this is your top element 2, and you need to return it. So where this 2 is present, it is in heads data. Head is basically the address of this node, and heads data is this 2, right? So you can simply return heads data. You're actually again doing this task in O of 1 only. You are just returning the heads data. Sorry, this should be data. Okay, you're just returning the data of head, this head node, right? So this is again done in O of 1. Now say I want to check the size. So how you can check the size? As soon as you insert an element, you can, first of all maintain your size variable with 0. As soon as you insert element, increment it with 1. And as soon as you delete the element, decrement it with 1. What I am saying is, let's forget about this case. Let's say my list is empty right now. I want to insert 1. Okay, let's maintain the size variable here. Okay, I want to insert 1. And this is my size variable, which is initially 0. As soon as you have inserted 1, your list is something like this. 1 here, and this is null, right? And you need to increment size by 1. So size will become from 0 to 1, right? Now if you want to insert 2, what will be done? 2 will be inserted here, and then in the beginning, right? And then 1 and then null, right? And the size will be 2 this time, because we have incremented it from 1 to 2. Now I'm doing insert 3, so 3 will be inserted here, and this will be 2 and 1, right? And this is your null. So size will be incremented from 2 to 2 plus 1, which is 3. Now say I want to delete an element. I want to delete some element from here. Okay. So how we can delete the element? You simply need to decrement the size by 1. Right. So delete the element. This 3 will be deleted and size will be decremented by 2. Like by 1, and it will become 2 now, right? Now say I want to check the top element. So the top element is again 2. So it will return 2 from here, right? And say now I want to check the size. What is the value contained inside your size variable? It is 2, right? And what is the size of this list? How many nodes are there? 1 and 2. 2 nodes are there basically means that my size variable contains the length of this list, right? And we can directly return size from here. You don't need to do anything, just return size from here, right? Okay, now let's check for is empty. So what my is empty function should do? It should check for size. That your size was 2 in this case, right? We have just seen. So what you need to do is, if your size is 0, we have seen this thing before as well, right? So you need to do something, else you need to do something. In this case, if your size is 0, basically means that there are no nodes inside the list. Just return true, that yeah, my list is empty, like my stack is empty, right? Otherwise, return false. Okay. So in this way, we can, and this one is also done in O of 1, because we are just, putting these two statements here, right? And it is taking constant time again. So all the operations insert, pop, pop is basically delete, pop is the inbuilt element, inbuilt function, okay? Let me discuss about the inbuilt functions as well. Stack is inbuilt as well. You can use inbuilt stack. So if you want to insert something, you have the function push. You need to do push and 1, right? If you want to delete something, there is pop function inbuilt, right? It will just delete the top element from there, right? Top is same in this case as well, in inbuilt as well, top itself. Okay, size is also same. Size function is there, and is empty is actually empty in that case. Okay, this is empty. If you want to check if a stack is empty or not. So these are the inbuilt, and these are what we have built, right? So I just hope stack is clear to you, and we have done all these operations in O of 1 time, right? Okay, now let's come to queues. Okay, so queues is again an abstract data type. Again, you have to follow some particular order to perform the operations. And again, this is also a linear data structure. Okay, but there's one difference here. It is different from stack in a way that entry and exit point are different here. Just think of a bank line, right? Say there are some people standing in a bank queue, 1, 2, 3, 4, and 5, 6, right? So say this person is depositing the money or like doing any stuff. So first of all, the task of like he'll be doing his task, right? And these will be waiting in the queue. And when he'll be going from here, like when he'll be removed from the queue, then he'll come into picture, right? And then this one, then third, then fourth one, fifth one, sixth one. So like the sixth one is inserted at the end, right? If some other person came, seven-person came here, so it will be inserted after six, right? And if you want to delete, so the first person will be removed from the list, right? From the queue, right? So stacks uses a different data, I can say different operation. So this is my sorry, what I'm saying. Queues uses a different operation, right? So if this is your queue and it contains these elements one, two, three, four, five. If you want to insert something, so it will be inserted at the end. Insertion is done from the end, right? This is your entry point, we can say. And if you want to remove an element, then this will be your exit point, right? So insertion is done from the end, and element is removed from the beginning, right? So it basically uses FIFO operation, the first in and first out. So who is the person inserted first? Let's say these are some six persons standing here in a queue. So this person is inserted like this person came first, so he'll be going at the first point, right? If you want to remove a person from the queue, he'll be removed, right? Then two will be removed, then three, four, and five, and six, and so on, right? So again, to implement queues, we have two options. Either you can use arrays or you can use linked list, right? So again, say this is your queue and you want to insert these elements inside it, right? So this is your array, say. You want to insert first of all, one is inserted here, then two is inserted here, third, fourth, and fifth, right? Now say I want to insert one more element just after it, right? Six. But your size of array is again fixed, right? You can't insert it after it. Because as I have told you, do whatever you want to do in this part, but don't go out of it. Don't go out of bounds, right? So we know that arrays will not work fine here. Again, we'll be using linked list to do this task, okay? So again, a class will be created. Let's name it as class Q. And again, we'll be having the same operations. Insert. So an element will be inserted, right? So I have inserted one. This is your Q. So one will be inserted here. Then so you want to delete element. So this one will be deleted now. So again, you want to insert two. So two will be inserted here. Then you want to insert three. So 3 will be inserted just after it. Then say you want to insert 4. So 4 will be inserted after it, right? And now say again you want to delete element from here. So which element will be deleted? The first element will be deleted, right? This 2 will be removed from here. And your Q will be 3 and 4, right? Just a second. Okay. So basically 3 has been inserted here. Okay, so now say I want to delete the element. So which element will be deleted? This 3 will be removed from here, right? Okay. Now say I want to check the top element. So in case of queues, we have front. Okay. So the first element will be removed. Sorry, we'll be returning the first element, that is 4, right? So 4 will be returned in this case. Okay. Now say I want to check the size. So size is again 1 because it contains one element only. So the size will be 1. Okay. And again for the isEmpty function, you have to do the same task. IsEmpty is again same. If your size is 0, then you need to return true from here, right? That it is empty. else you need to return false. Okay, so these are the functions that we need to implement in case of queues as well. So let's start the implementation. The first thing is insertion. Say I want to insert one inside the queue. So this is your queue, say it is empty right now. So what will happen as soon as you will be implementing it with the help of linked list again, right? So as soon as you will be doing this, this node will be created, one data one inside it, and this will be null, right? Okay, so one will be inserted here. Now say I have called insert two. So two will be inserted just after it, and a new node will be created with two data inside it, and this will be null, right? Okay, so again we need to connect them. Again we have the same method to connect it. Just write that, say this is in 100, this is in 100, and this is head, right? So just remove this thing and write the address of the next node, that is 200, right? And this will be a new node. As soon as you'll be doing this thing, a link will be created like this. Okay. Now say I want to insert 3. So what I need to do, a new node will be created with data 3 inside it. And this will be null, right? So say this is on 300 and this will be replaced by 300 here, and this link will be created like this. Okay. So now say you want to insert 4 again. So again you need to insert 4 here. So just create a new node and take 4 here, and this link will be created, right? And this will be replaced by this 400. So a linked list has been created with data 1, 2, 3, and 4 inside it, right? And this is null, right? So if a new element comes, if you want to insert 5 here, 5 will be inserted at the end, right? Okay, so how much time will it be taking? Like say I want to insert 5. So you need to traverse over the complete list. This is your head node. You need to traverse over the complete list and come to the end and insert 5 here. And this will be null now, right? So basically you are traversing over all the elements, all the nodes in the list, right? Which is O of n, right? It will be taking O of n time. Okay. So again we need to improve it from O of n to O of 1. So again we need to do something else. So let's check how we can do that. So say this is your insert function and you have inserted 1 inside it. Again a node will be created with data 1 inside it, and this will be null, right? Okay. So this will be your head now. Now let's again take a tail variable. Tail will be pointing here. Okay, and say this is an address 100. Now you need to insert 2. So a new node will be created, which is with data 2 inside it, and this will be null, right? So this is your new node, and what you are doing is in tails next, you need to put the address of n, the new node, right? So say this is on 200, so you need to write 200 here. Okay, and this link will be created, and then do tail is equal to tails next. So now your tail will come here. This will be your tail now, right? Again, if you want to insert 3 inside it, so to insert 3, this is your new node, and this is 3, and this is null, right? So what you need to do is, again you need to do the similar task. In tails next, put n. This is your new node. Say this is a 300, so it will be 300 here, and this link will be created, right? And now your tail will come here. So if you'll be trying to insert the next element 4, so how much time will it be taking? It will be just playing with the last node of the list and the node that you want to insert, right? So this is the node that you want to insert, and this is the last node of your list. So it will be inserted like this, right? This link will be created. So we are just performing these two statements to insert the new node, right? Which is taking a constant time k, and it will be done in O of 1 time, right? In the previous case, that was taking O of n time. Now we are doing it in O of 1 time only, right? Okay, so push function like insert function is working fine in O of 1. Now let's check for pop function, like the delete function. So this is your list 1, 2, 3, and say 4, right? Okay, this is your head node. If I want to delete something, this should be your queue, right? First of all, 1 will be inserted, then 2, then 3, then 4, right? So what will happen if you want to delete an element? The first element will be deleted. This one, right? We know this thing in queue that the exit point will be the first one, right? So you need to remove this one. So say I have called the delete function. What will happen as soon as you'll be calling this delete function? You need to delete this first node, right? So again, we can take a pointer variable temp. Just you need to do is node star temp is equal to head, right? So temp will start pointing here at the first node. Now what you need to do, just take head to the next node like here. So you need to do head is equal to heads next, right? And then you can simply delete temp. As soon as you do these, as soon as you perform these statements, your first node will be removed and head will be pointing here at the next node, right? Again, what I need to do, say I want to delete the next element. So this one has been removed. You need to remove two now. So this two should be removed. Again, you need to perform these operations like these statements. And in the same way, you'll be taking a temp pointer variable here. And then you need to do head is equal to heads next. So head will come here. And you need to delete your temp. So this will be removed. And your queue will be 3 and 4 only, right? So this is what we actually wanted end, right? So what we are doing is we are performing these statements in O of one time only because it is taking some constant time. We are not traversing the list. We are not going over all the nodes, right? We are just taking O of one time here. So your insert and delete function are being done in O of one time. Now let's check for the top and other functions left out. So say you want to check the top, which we call as front in case of queue, right? Inbuilt queue uses the front function. Okay, so this was your list left. This was 3 and this was 4 and this was null, right? And here I have my head pointer, right? So what should be returned, which is the front element 3, right? So what you need to return is simply return front's data. Sorry, head's data, because this is the head node, right? So it will give me 3. And now say you want to check the size. In the similar manner, if you want to insert some element, as soon as you insert something, increment the size. Do size is equal to size plus 1. Okay. So the next character for the code is R. I repeat, the next character for the code is R. Okay. So now say I want to, this is my insert. As soon as I want to insert something, so I need to increment the size, right? If I want to delete something, then you just do one thing, do size is equal to size minus 1, right? So your size will be basically containing the number of nodes left out in the list, right? And you can directly return size from here, right? Again, if you want to check the is empty function, so what you need to do is just check if your size is 0. So in this case, your size is 2 actually. 1 node and 2 node, right? So size is 2. So this should be returned true if it is 0. But as our size is not 0, we need to return false. And as you can see as well, that there are some elements present in the list. There are some nodes still present in the list, which are 2, right? So it should return false and it is returning false, right? Okay, so now let's discuss about the inbuilt queue. So as I have discussed insert function, in inbuilt queue, it is enqueue. If you're using the delete function, in inbuilt queue, it is dequeue. And in case of top, we have front. And for size and is empty, we have the same as we have in stack. This will be size only. And for is empty, we have empty function. Okay. So this is the status. This is my inbuilt queue, and this is what we have created. The functions work in the same way, right? So this was all about what I need to discuss in this session. I just hope everything is clear to you. And the fourth character is R. I repeat, the fourth character for the code is R. Sorry, T, T. The fourth
Actually, the
character
fourth
is,
character is T.
yeah.
The first four characters combined as R, C, E, R, and T. So Thanks, Himanshi, for joining us today and explaining stacks and queues in such a simple manner. I hope our viewers have must have understood everything about stack and queues needed as basics of stacks and queues, right? So, thank you, Himanshi, for joining us today.
Thank you so much.
So, hello guys. So, the first four characters to avail the certificate or be eligible for the certificates are C, E, R, and T. We are just now left with the fifth character or the last character, I would say, that would make a code which is your eligibility criteria for the certificate. And upon telling me the correct code in the comments, I would let you guys know the process by which you can avail your certificate. Fine. So. As in the beginning of the session, I told that we have something big to announce. So the announcement goes like this: that we are providing a huge cashback of 90 lakhs rupees. Like we are providing a huge cashback of 90 lakh rupees on our courses, and that can be availed by purchasing a course named Complete Interview Preparation. That particular course comprises of everything. It comprises of everything. It has programming languages C++ and Java. It comprises of object-oriented programming languages, and it has data structures, algorithms. It has object-oriented design. It has computer subjects like OS, DBMS, networking. And I will just simply share my screen and show you guys about the course link. So if you open our website practice.geeksforgeeks.org/courses, you may see this banner which tells that we are providing a 90 lakh cashback pool. And to be eligible for this cashback, you need to purchase this course, Complete Interview Preparation with Doubt Assistance. This course consists of everything. Like it has a lot of features. You can see the features here. You can see the detailed course content here, and the most important thing that we have done in this particular course and almost every course of ours is we believed in data. We have a huge pool of interview experiences that we receive on a daily basis, and we have analyzed all of those interview experiences, like 10 or 20,000 interview experiences. So we have that data that what all things are actually asked in companies. Like if you go through CS subjects, if you go through this section CS subjects, you must have observed that these subjects like operating system, database management system, and computer networks have a lot of things to learn about, right? But we have tried to stick to what all things are asked in interviews. So we have analyzed a lot of interview experiences, we have analyzed a lot of data, and we have come up with a very concise syllabus, I would say, that would help you to prepare in limited time, right? So this course is very well prepared, very well reviewed, and we are providing 3,000 cashback to the first 3,000 users who will purchase this course. You may see the details right here. I will add the course link in the description. And along with this, we also believe that there are a lot of things which are necessary to which will help you to excel in your software engineering career, right? So we have a live courses section as well. You guys may check this out. We have a live courses section, and this section basically have a lot of courses on software engineering. Like it have Java backend development course, it has design pattern course, it has full stack development course. So I would just repeat this thing. We are providing a 90 lakh cashback pool, and it is available to the first 3,000 users. The first 3,000 users will be eligible for a cashback of rupees 3,000 each, right? So this was all for from our side. So the code was CERTI. The last character was I. The code is CERTI. And what you guys need to do to avail the certificate is I will add a link in the video description that will redirect you to a form, and you need to just fill up that form, and you will receive the certificate within 7 to 14 working days. Fine. So that was all about our side. So this webinar or this workshop ends here. I hope you guys have learned a lot from this webinar and this session. We have also linked the link. We have also provided the link in description to the previous session of yesterday, which was based on arrays, time complexities, and a lot of other things. So do check this. Do check that out. And if you have any queries, you may follow me over LinkedIn. I have added the link to my LinkedIn profile also in the video description. So that was all from our side. Hope you guys excel in your career, and hope this workshop have helped all of you. So do check out the links in the description. Do check out the links in the description and make sure you avail the 3000 discount. And it is not for everyone. It is for a limited time offer, and we have decided to provide that to first 3000 users only. Like this is we are doing this for the first time, and the first 3000 users to purchase the course complete interview preparation without assistance would be eligible for a cashback of rupees 3000 each. So thank you guys.